Today, we're going to learn how to use the map data structure. Hello, I'm James Helfrich. The map data structure can be kind of tricky to use because every element in the collection has both a key and a value. The map is going to store all the elements according to the key in sorted order. We can access every value based on the key. Let's take a look at how this works.
The map data structure has the same constructors we find with all the other containers: a default constructor, a copy constructor, a move constructor, and a range and initialize constructor. We'll start by including the map library. We have to do this because the map is not built into the standard template library. Now the full name is std::map, and then we have to specify two template parameters: the key, which I'm going to make a character, and the value, which will make an integer, and I'll call this m. Now the default constructor will create a map of size 0. And sure enough, when I run it, we'll see that I have size 0. Okay, now we're going to initialize this map with a collection of elements. And each element in a map is a pair. The pair is the key and the value combination. So I'm going to make this a pair of char int, and I'll call this pair v, which is going to have the v and the number 5. And then I'm going to copy this guy to make several of them. Let's see here, v, and then we'll have x for 10. As you can see, I'm kind of doing Roman numerals here, and I'll do l for 50. And I got to make sure to change my variable names from PV to PX to PL. And now I have a initializer list, and I'm going to pass PV, PX, and PL. Okay, when I run this, I expect to find a map of size 3. And each one is going to have 3 elements, and each element will be that key value pair. And there they are. Notice how they're stored in order according to the key, not according to the value. So in other words, L will be first and then not 5. Okay, now I can also make a copy constructor, so I'll have the source be in the V, the X, and the L, and the destination will be the same. So now both the source and the destination will have 3 elements. Sure enough, 3 elements. Okay, and all 3 of them are in there. Now that's the copy constructor. Now I can do the move constructor by saying std::move. And this will steal the elements from source and put it into the destination. Therefore, source will be of size 0 and destination will be of size 3. And sure enough, that's the case. Okay, the next I'm going to learn how to assign values to a map. I have the copy assign, the move assign, the initializer assign, and of course swap. To demonstrate this, I'm going to need some more pairs. So I have the V, X, and the L, which are in the source. And in the destination, I'm going to have, what should I have here? I think I'll have the PI, the PV, the PX, and I'll just make a whole bunch of them. So now I'm going to have the source is going to have 3 elements, the destination is going to have 6. Now I'm going to say destination equals m source, and now I expect both of them to have still the same 3, and northern destinations 5 are going to get overwritten. Okay. So now when I do std move, then I'm going to steal sources values and put them into the destination. Destinations 5 are still going to get removed. And that's the case. Source is 0, destination is 3. And the last thing I'm going to do here is I'm going to swap destination with the source. And now I expect destination to have 3 elements and source to have 5. And let's see if that's the case. So when I run it, yep, destination has 3 and source has 5. And there they are. The map also has an iterator. The interesting thing about the map's iterator is that when you dereference the iterator, it refers to a pair, both the key and the value. All right, to demonstrate this, I'll have my 5-element map. And now my full name of my iterator, std::map, the key, the value type, : iterator, it equals m.begin. Now when I run this, I expect it to refer to the first element, and notice that it's a pointer to both the key and the value. First is the key, second is the value. All right, now I can also use the short version, which is just auto. Now, by the way, the first element is the first element in sorted order according to the key, which is going to be the C. And so once again, I get the C there because it's the first element in sorted order. Okay, a super common thing you do with the iterator is you want to iterate through all elements. And so what I'm going to do is I'm going to say int sum for auto it equals m dot begin, it not equals m dot end, it plus plus. And now we do the same kind of thing all the time when we walk through an iterator. Now the second element is going to be the value, and I want to sum them up. So let's see here. I'm going to initialize my sum equals 0. I'm going to run it again, and that should sum up, let's see here, 100 plus 50 plus 1 plus 10 plus 5, which is going to be 166. The coolest method in the map is a square bracket operator, allowing us to retrieve an element based on its key. To demonstrate this, we're going to have the same map we had before with 5 elements, and we're going to say, hey, give me the value based on the key C, and that should give us 100. Let's see if that works. And sure enough, it gives us 100. That's the value. So I looked up the value based on the key. Now, we can also look up x, and x should be 10. And sure enough, there it goes, right? Now the cool thing about the square bracket operator is not only can we view a value, but we can also set a value. In this case, I'm going to set the value of x to 9,999. It's no longer 10, which means, well, I'm no longer doing a very good job with my Roman numerals. There are 2 main ways to add elements to a map: the square bracket operator and the insert method. To demonstrate how the square bracket operator works to insert a new element, I will say, hey, D equals 500. And now instead of having 5 elements in my map, I will now have 6. And notice how D is added in there. Once again, the key is sorted in alphabetical order. Now, in order for me to use the insert method, I need to create a pair. So I'm going to create a pair, and once again, I'm going to do D, and D will be the value 500, and this should work exactly the same as if I used the square bracket operator to insert. And you can see that the square bracket operator is way more convenient than creating a pair, but it has exactly the same effect. And there it is. Note that the set and the map are both the same, and then I cannot have duplicate keys. So if I try to create a new key, then the new value is just going to get ignored and the old one will remain there. So you'll see that x remains as 10. The map allows us to remove elements with erase, either by providing a key or an iterator. I also have the clear. So I'm going to start by erasing a value based on the past key. So in this case, I'm going to erase the value, which one? X. So now I should have 4 elements in my map where X is no longer in the list. And so sure enough, I have 4 elements and X is not there. Now, if I want to erase based on an iterator, then I have to create an iterator. So I'll call it equals m.begin. And that's going to be the first element in the map, which is the lowest key, which would be the value C. So now once again, I'm going to have 4 elements, this time without the C. And sure enough, not the iterator, the map, there we go. And the C is no longer there. Finally, the map has 2 status methods, size and empty. So size is going to return a size t, which is usually an unsigned integer, and empty is going to return a Boolean. Now, initially I have 5 elements in my map, so I expect size map to be 5 and empty map to be false. And let's see if that's true. And empty map is false, sure enough, and size map is 5. Now, if I say m.clear, then I expect my size to be 0, and I expect my empty to be true. And sure enough, size map is 0, and empty is true. You can learn more about the map and many other data structures in the C++ data structures textbook.